In this video, I'm going to show you how to model CNC operation number 1 from mill project number 1. Now notice we have to go ahead and first run CNC operation number 1, take the part out of the CNC machine, and inspect the part's height, the width, the length, the contour's height, and then use the optical comparator to figure out the chamfer size. Once you've done that, you can then proceed to modeling CNC operation number 1. So looking at these values and looking at the different views here in figure 3, I need to go to SolidWorks and create a brand new file. So the first step is File, New. I'm going to select Part and press OK. At this point, it brings me up with a blank part environment where I have my 3 mutually perpendicular planes here, my front, my top, and my right. And I'm going to go ahead and hit my Features ribbon bar and use the Extrude Tool to make my first feature. Now moving back, before I select my plane, I want to look at my drawing here, and I notice that my top view has my 2 by 4.1 inch rectangle on it. Therefore, I'm going to move back to SolidWorks and select the top plane to sketch a rectangle. Now I'm going to lock the corner of the rectangle into the origin and grow it out to be very close to the size. However, in order to specify the size of this rectangle, I'm going to use the Smart Dimension tool to click on the edge and drag it outwards. I'm going to type in 2.0. Now next, I'm going to go ahead and use the Smart Dimension to dimension 4.1. At this point, I have fully defined my rectangle the rectangle, by 2 by 4.1. And I'm going to go ahead and hit Exit Sketch in order to go to the 3D portion of this feature. Now, looking at this feature, I have to determine the distance to extrude the 4.1 by 2 inch rectangle. Moving back to my inspection data, I see that the overall part height is 0.492 and the contour's height is 0.303. The difference between those numbers is going to be the height of the rectangle. So when I go back to SolidWorks, I'm going to do math in the actual dimension window here. So I can do 0.492 minus 0.303 tab. I end up with a result of 0.189 of an inch. Remember, your numbers are going to be slightly different compared to my numbers. It's based off the actual part we inspected. So at this point, I'm going to go ahead and hit the check mark, and that will go ahead and create my first feature, a rectangle that's 0.189 tall. In order to make my feature make sense, I'm going to move over to the design tree over here and right-click on that feature. I can now go to the feature properties and type in a name that makes sense, like base rectangle. Press OK. At this point, if I needed to go back and modify anything, I could do so very easily by right-clicking on the feature. If I needed to change the 2D profile, I would select Edit Sketch, hit Spacebar, Normal to, and then I could double-click on the values and change the size of my sketch if needed. When I'm all done editing it, I hit Exit Sketch, and my 3D component comes back into play. Now if I wanted to change the 3D component, I could right-click on the feature, go to Edit Feature, and change the size right here. Hit check mark. Okay, now we're ready for our second feature, the contour. So moving back to the part, you'll see that the contour is 4.002 by 1.877 wide and tall, or length and width. So to do this, I'm going to move back to SolidWorks. I'm going to select Extrude. I'm going to pick the top face of the rectangle. I'm going to hit Spacebar and Normal to. This brings the plane I'm sketching on normal to my view and allows me to select the appropriate sketch geometry I want to make. So I'm going to select Rectangle, drag out a rectangle, and then use Smart Dimension to size the rectangle. 1.877, check mark, and then 4.002, check mark. I've sized my rectangle, but now I need to position my rectangle. To do so, I'm going to go ahead and dimension from the midpoint of my rectangle to the edge of my part and place the dimension. So now we're going to relate this dimension to the other dimensions. To do that, if I want to put this exactly in the middle, I could simply go equal, parenthesis, this dimension divided by 2, close parenthesis. I'm going to add 50th thou to that because the overall length is 100th thou, so I divided that by 2. Or if I want to go ahead and get even trickier, I can add 100th thou divided by 2. And what that does is it places the dimension directly in the middle of my part. Now, another thing you could do would be you could dimension from that midpoint to that edge, drag out, and you could write equal to the overall length let me rephrase that. I could dimension from this midpoint to this edge, drag out, go equal, parenthesis, this number divided by 2 plus 0.125 divided by 2, close parenthesis. What that'll end up doing is centering my part based off of the actual dimensions we have for the rectangle right there. So the location is related to the actual size. At this point, I'm going to add the fillets to my part. I'm going to add the fillets in a sketch instead of using the feature. So to do this, I'm going to go ahead and hit Sketch Fillet. I'm going to click the size of the fillet, 0.25, key that in the fillet parameter. And I'm going to create one fillet this way, actually. And I'm going to show you the fillet this way and using the fillet tool. So at this point, when I hit Exit Sketch, I need to determine the overall height of this contour. Moving back to my drawing, you'll see that it's 0.303. So what I'm going to do is go back to SolidWorks and type in 0.303 tab and check mark. Now I fully have created the second protrusion, and I did this on purpose because I want to show you the difference between the sketch fillet and then the fillet tool. Now notice the fillet tool may be an easier way to add fillets once you already have a 3D feature or a sharp edge on a 3D feature. So when I click fillet here, I simply go down to the bottom and I type in the fillet size, and I pick the vertical edges that I want to round and hit check mark. Remember, there's more than one way to make your model. The best answer is the quickest method. So now looking over at my feature tree over here, my design tree, I have a base rectangle. I'm going to right click on my second extrusion and change that to contour profile. Press OK. Then I'm going to right click on the fillet feature property. I'm going to call it corner round. OK. Now the last thing I need to do in order to model this part is add my chamfer. Looking back at the drawing, you'll see the chamfer was supposed to be 45 degrees by 25 thou. I ended up with a 23 thou chamfer on my model. Therefore, I'm going to move back to SolidWorks. Underneath the fillet tool is a chamfer tool. I'm going to select on chamfer. I'm going to select the degree, and then I'm going to type in the 23 thou chamfer size and pick the edge of the part. Notice it fully previews the chamfer. I hit the check mark, and I have my model fully created now. In order to make sure it's oriented correctly, we're going to hit the space bar, and we're going to pick the pictorial isometric view. Notice we have our top and our front view there. it's oriented correctly like we see our top and our front view here in the Op1 first article inspection from the lab manual. Now the last step would be go to File, Save As, your last name, Op number 1 mill. And make sure you save it in the same folder you're saving all your files. Now, we are fully done with the Op number 1 solid model. It's time to make a drawing. Join me for the next video to make the drawing. Can't wait to do it. See you then.